Well, hi guys, welcome to another exciting episode of Matrix Uploaded. We're going to be looking at calculus today and in the next few episodes. Let's have a look at what calculus is about. Nelson, let's go through this.
All right, let's have a look here, guys. It says calculus is probably one of the greatest creations of human thought. It has become a powerful tool for solving important problems in the world of mathematics and science.
Okay, it was basically, guys, during the 17th century that calculus was invented by mathematicians and scientists as a means of investigating certain problems which involved motion, movement. Okay, and the greatest pioneers, if you have a look, were Newton, Leibniz, and do you remember Cauchy? Probably one of the greatest mathematicians of all time, probably the most exciting mathematics that you're ever going to do, and the most useful. So let's have a look. If we could carry on, it says modern-day applications of calculus, including the investigating of the rate of growth of populations. Look at this. Predicting the outcome of chemical reactions. Look at that. Measuring instantaneous changes in electrical current.
Describing the behavior of atomic particles. Estimating tumor shrinkage in radiation therapy. Forecasting economic profits and losses, determining the spread of epidemics.
And then the other thing, guys, like motor vehicle emissions, it also deals with that. On ozone, if you take emissions, you know how cars give off, all that kind of smoke, that gas, that motor vehicle emissions. And what it's doing is it actually looks at ozone depletion. What is it doing to the environment? This is what calculus does. It is the most exciting thing. And also vibrations in mechanical systems. So in so many fields of life, calculus can be used. And we're going to start at the very beginning and look at a thing called limits. So let's have a look. If we take the concepts of a limit, there's a parabola. Let's have a look. X squared plus 1, we just made that up. And what we're going to do is we're going to do a little bit of work on the parabola graph. But more so, guys, we're going to be looking at the concept of a limit. Okay, now let's pick an x value for this parabola. Should we have a look? Nelson, what should we choose?
Right, let's take an example of when x is 1.
Now remember, that's just chosen. You could have picked x as -3,
-1,
anything.
whatever.
We've just selected one value for x. Now check this out.
Right, and then we're describing the concept of limit here. And then we're saying, this is the graph. When you replace x by 1, you get 1 squared plus 1, which is 2. And then what happens? The value of y is 2 there. And we're saying when we approach 1 from the right and from the left, then the limit is 2. We get this value of 2. And then what more can you say about this, Mark?
Okay, very important, guys. Listen, this is how this limit thing works, okay? You've got a parabola, you've picked an x value, and the x's, if you take them, x values can approach from the left and the right. We're approaching, we're getting closer to 1. But at the same time, the y values for the parabola, if x approaches 1 from the left and right, the y values are approaching 2. How did we get it? Look at the slide again. As Nelson pointed out here, we worked out if x is 1, the y value is 2. Okay, and then what did we do is we then approached, and we say the limit of fx as x approaches 1 is going to be this. The fx is the graph, and what are we going to do? We sub in. Notice the notation, we're dropping the limit. Okay, very important there, which then gives us 2, which is the y value. So really what the limit is, it's if you approach 1 from the left and right, the y values on the graph are going to 2. And the limit is the y value approached. Okay, now in advanced program maths, we get quite technical with this. But for our purposes, a limit is really the y value that you approach. Okay, look at the slide again. And the important thing also, guys, is the f of 1. Fx notation. Fx notation. Let's just quickly do one more example. and then we're going to continue. Take the first example. Nelson, do you want to go through that quickly?
Right, let's have a look here. It says the limit of 2x squared plus 4. As x tends to negative 4, what happens? You simply replace x by negative 4, and then the limit is 36. From replacing x by negative 4, then you just solve this. Negative 4 squared is 16 times 2 plus 4 is 36.
That is the y value approached. Now, in the next lesson, guys, we're going to be taking this further. We're going to be looking at the concept of other kinds of limits. Yeah. Okay, and then there's a beautiful one coming up, the limit that we call gradient from first principles. So, in the next lesson, don't run away. We're going to be doing some more beautiful work on limits.
Cheers.